Hi everyone. Hello, thank you. We'd like to welcome you today to Keith and Mario's Guide to Fast Websites. Now, I apologize in advance because when Mario and I were coming up with this talk, Mario asked me, what should we call the talk? And I was trying to think of the lamest possible name we could come up with, and that was Keith and Mario's Guide to Fast Websites. And there's a car in the background, just if you didn't quite get that, because cars are fast. So, a little bit about ourselves. Mario is the the lead maintainer for a site called howgoodischeese.com. It's a bit of a cheesy title, but if you want to know howgoodischeese.com, you should definitely go to howgoodischeese.com.
Now, Keith is actually originally from South Australia. In 2007, he won the South Australian Magician of the Year. Close-up magic, folks. Close-up magic.
Yeah.
Moving on.
Whoops, that was not planned. I'm sorry. So we are both from Australia, this country here. Specifically, a little bit north of here, suburb called Brunswick, which is right here. Now, the natives look a little something like this. Go hipster or go home is a common term. I'm not quite sure.
They're very peaceful, make great coffee, love them.
Nice people.
It's good.
Great
Good place
people.
to live.
Really nice. We work at Envato by day. That's our day job. And by night, we work on this site called Desktopper. You may have heard of it. Desktopper is... Thank you. Thanks, Mum. Desktopper is a site that allows you to upload your favorite wallpapers. They kind of get collated on the site and allows you to sync those wallpapers to your Dropbox. So you set your desktop wallpaper source to be the Dropbox folder, and whenever you sync something on the app, automatically downloads and it appears in your background. Yay! Now, how many of your chat rooms look like this during the day? I think I prefer to use GIFs more than text. I find them much more fun, and it annoys everybody. So, we love GIFs. We like them a lot. When we were preparing this talk yesterday, I saw this tweet come up. This was not planned whatsoever. But apparently Lincoln Stoll also likes making GIFs of Ben Schwartz getting punched in the face. So, it's not just us. These guys love him. I didn't ask him if I could do that. So, today, Mario and I are pleased to announce to you a new app that we've created called GIF Topper.
Ooh.
I know. You're very excited? This guy's excited. Now, don't know why I moved so fast, but this is what GIF Topper looks like. There's a list of GIFs. You can hover over the GIF, a little loading symbol. Look at that, loading. Beautiful. The GIF plays, and the bottom left of each GIF there's a little cloud icon. What that'll do is that'll let you sync that GIF to your Dropbox. So you can just...
This GIF here is very important. Make sure you remember this for future reference.
Yeah.
Yes.
Well, it's right now, actually. Who is this guy?
Yes.
Yeah,
yes. Well done, sir. Well done.
Yesterday, I'll tell you a story. Yesterday, I was showing this to David Goodlad, and I was like, oh, this looks like Lincoln Stoll. And he said, that's Zach Galifianakis. Like, what? Zach Galifianakis is the guy from... what was it?
The Bachelor Party, the Hangover.
Yeah. So he was like, Zach Galifianakis. I'm like, it's not Zach Galifianakis. He said, it is. I'm like, I bet you $10 that it's not. So Mario walked.
I was convinced it was. I was trying to tell Keith that he should give him the money because I was convinced that that's him. I thought he was in a serious role before his comedic days. So.
I googled image searched it. First result, bam. Oh. It's not. So I used the powers of the internet to try and crowdsource the answer. Now, I didn't tell Mario this, but I kind of abused the Desktopper Twitter account and tweeted a picture of the guy and saying, who is this? Now, within a few minutes, an hour later, this guy responded with a YouTube link to Robert Redford. And it was great. And I went to the link, and there's a video of him in this film. It's coming up. Ready? Wait for it. Wait for it. There it is.
There we go.
Yeah.
Yeah.
Robert Redford. So I won the $10. I gave away a free lifetime membership to Desktopper, which is worth $30. So...
But you won the bet, so that's important. Yes.
I won the bet. That was the best part. So, this is GiftTopper.
Awesome. So we built. So we built this. We built this site. We pushed it up in a small amount of time, and everything was great. But one thing we did notice was it was a little bit slow, especially when you get there for the first time. So we thought we'd do some benchmarks and figure out how slow it was, and this happened. 9 seconds. Now, a lot of you might think that it's because of the animated GIFs. We actually have a preview image for each of the images. So just to load it, we just need that single preview image. So it's not doing, it shouldn't be so slow. There's no reason for it to be this slow, and we were really puzzled. So this is us.
There's a lot of animated GIFs in this presentation.
It's a very much a yes.
FYI.
So we were really puzzled as to why it could be so slow. And we had a look at our setup, and there was nothing odd about our setup. We were using, platforms and tools that we always use. We're hosting it on Heroku. That's fine. Heroku's always great, always quick for us, not a problem. We looked at our stats as well for our website, and you can see it's about 900 kilobytes, which seems a bit big, but if you look at the actual average page size on the web, it's actually larger than this. So we have a below average page size, but it takes 9 seconds, which is much slower than the average web page. So we were trying to figure out why that was. So we decided to make it faster. And we had a particular goal in mind. So we wanted to have our web page load in under 2 seconds. So that we set this goal to make sure we have something that we can achieve. So another thing to note is we're making sure we've just launched this yesterday, right? So we don't have any users. We might start off with a few users, so we want to make sure it's fast for them. We're not necessarily going to concentrate on concurrency. So users aren't going to care if we can serve 10,000 users. They just care about their site loading quick. So
we want to make the site faster for our 2 users.
Yes, those guys. Me and yes, so far.
Oh, and Mum. Oh, thank you.
Yes.
Thank you so much. It's giftopper.co. We forgot to mention the URL. But don't look at it now. Watch us.
Okay. So we consulted someone much clever than us. This fella, Steve, seems very clever, works at Google, must know his stuff. And he says, look towards the front end if you want to make improvements, because most of the response time is actually spent there and not on your back end. So this is what a typical waterfall looks. This is a breakdown of a website loading. So at the top, you can see the first bar is your HTML markup. You've got your CSS, your JavaScript, and your images. And this is what it typically looks like. And if you have a look, the actual web page loading itself, so the app serving it up, the latency, the response, all getting there is just a small fraction of the entire time. So, where are we? So we're going to concentrate on this front end metric here. Additionally, if you look at the top 10 websites, the majority of the time is spent on the back end, on the front end here as well. So it's definitely the thing that we want to focus on.
This bit here.
This bit here.
We're going to optimize this.
The whole thing. Yes. So we had a problem, which was how do we measure it? We're in Australia, which means if we're hosting in the US, our latency is going to be quite high. Things can get very varied, and it's very easy to run benchmarks and have really wildly varying times. Not milliseconds, not hundreds of milliseconds, but you can even get seconds of latency of difference when running tests. So we wanted to find a way that we could accurately, or at least give us a good idea of if it actually is quicker or not. So HTML5 has this cool thing called the Navigation Timing API. Now what that does is it means when we load a web page, the browser will record figures, it will record timestamps of certain events, so things like the DNS lookup, when the request has started and finished, the DOM, so when the DOM starts loading, when it finishes loading, blocking scripts, asynchronous scripts, all that sort of good stuff. So we wanted to use that. We couldn't really find too many tools to do what we wanted though, and have a consistent run, because once again, if we just run this once, it can very wildly vary. So we want to make sure we're getting some measure, and we can be confident that our changes are making effect. So we built this little thing called WBench. So what WBench does is...
Can you go back a slide?
Yes.
You notice that it's already at version 2.2, 0.2.2.
Yes.
That's how good it is.
I had bugs.
Great, but release shit.
Semantic versioning, very good. So this is what it prints out, which is excellent. So we put it into a website. Here you can see we're pointing at desktopper. We run it through 10 times and we figure out all our loading points. The last column is actually pretty cool because we can work out our standard deviation. So we know if this is a very low value like here where it's around 40 milliseconds, we know consistently when we ran this that our times are roughly the same, and it's an accurate measure of the performance. If our standard deviation is wildly varying, if it's quite high, then we know that we should look into why that's happening. There might be something causing that, but it's not as accurate a measure unless we can get that time down. So the problem with this is there's all these really cool events. We don't know which one to look at. There's some that looks like they might be relevant, like maybe it's the DOM complete. Do we look at load event? We didn't know. So there's on the W3 C site, they have specifications, but they're written as a specification. So we found this cool site that explains it in plain English that we can understand. And we found the one that we want to concentrate on is DOM complete. The reason for this is DOM complete is fired after the images are loaded, and we have a GIF website. So it's quite obvious that we want to concentrate on this metric. For other sites, you might be focusing on other things like time to first byte, some other metrics, but for us in particular on this app, this is the figure we want to look at. So it's just there, the DOM complete, so that's what we're going to be looking at. Additionally, we're on a pretty beefy connection, so we wanted to make sure that...
We have the NBN at home.
What up? It's very cool. So we wanted to... Sorry. We'll set up a Wi-Fi access point at our house later, you can all come. The Australian average connection seems to be about 5 megabit from the statistics I got online. The upload speed I can find anywhere, so we've just estimated about 2 megabits. It's probably a bit slower, but 5x2 should be a bit quicker. Yeah.
Very accurate, very accurate.
Yeah. Roughly this average Australian internet connection. Another thing to note is our tool only does first load times. When WBench runs, it actually opens a browser, connects to the site, grabs all that information, closes the browser so we're completely fresh, and then does it again. So we don't have any caching to work with at the moment. We want to make sure our web page is loading quickly for the first time. We want to wow someone when they come to our site. And additionally, if we can get that time down when they come subsequent times, as long as we're doing sensible things with caching, that should additionally be quicker if we can get that first load time. So that's the thing that we're going to concentrate on.
Yeah. First impressions matter, essentially. So we got to make sure that first impression of your application to your user is super fast and super quick. There's really no point making every subsequent request faster with caching because they've already left. They've already left, according to Mario. Oh, yes. So another tool in our repertoire is webpagetest.org. Now this tool is invaluable. It looks like a site from about 2000, but it's super awesome. So what it'll let you do is let you put in any URL, and that'll give you a heap of information about the front end performance of your application. The Google Chrome developer tools, the waterfall chart inside there. This has similar functionality, but it allows you to specify your location. So we specified our location as Australia. You can set it in China, in Japan, in America if you like, and you can also change the browser, and it gives you a consistent set of numbers across all those things, which is invaluable.
It does some other cool stuff where we can actually get a visual. We can actually get two sites, get them to load up side by side, and it'll actually produce a video for you at the end. So it's really cool for that. We didn't do that.
No, we didn't do that, but you can. So this is that waterfall chart that we spoke about before. Now we benchmarked GiveTop at this time. Now, if we move over to the other side of this chart, you'll see a green line here. It's pretty faint on the projector, but it's right there. This is the start render time. Now, you want to look at this line because this line represents the time and when users start seeing something. It's no longer just a white page. They start seeing an image load, an ad load, some text load. They see something. If we move further to the right, this is the page load time. This line indicates when your page is done. It's starting to idle. It's undone, we're good. Now, what we want to do is try and optimize this first bit. If you look at the headings at the top, you see that 0.5, it's a bit small. to the green line, which is like 5.7. This is 5.7 seconds of time where the user sees absolutely nothing. Why? They've clicked on a link from Google and they get a white page for about 5.7 seconds, which is
very bad.
Very, very bad. So what we're going to do is try and optimize this. Now, if you look at the CSS and the JavaScript there, if you click those things in webpagetest.org, they'll give you a size. Now, what we want to try and do is, the first thing we're going to attempt is try and make those files much smaller. This is probably pretty basic stuff, but we thought it was pretty important to cover. What we want to do is try and make those files much smaller. Smaller files equals faster downloads equals...
Happy fun times.
That too. So, the first step is we're going to try and minify the CSS and JavaScript. Now, if you're using Rails, this is done, so you don't have to worry about it.
We turned this off.
You're sweet. We actually turned it off to get our measure.
If you're using another React framework, you've got you can use Sprockets or something like Jamit, the other one. So,
one thing that we need to note that is that this may not work in Almost Sinatra.
Yes.
We're not sure.
Almost Sinatra, we haven't tested, so...
it's unknown. So just put a issue into the Sinatra.
And Constantine will add support for you,
Absolutely. So we minified the CSS and the JavaScript, and we shaved a second.
Yes.
Yes, calm down. So we've made our files smaller, but what else can we do to make them smaller again? Enter stage left gzip. So what we're going to do is... everyone know what gzipping is? Yes? No? Essentially what it is allows us to take the assets on the server, essentially zip them, send them to the client in a much smaller payload, and have the browser deflate it. So it just reads it again. Usually you want to do this setup at the Nginx or Apache level, but we can do it in Rails. If you're hosting on Heroku, none of your all HTML responses aren't gzipped by default on the setter stack. The Bamboo stack used to, I think, but setter doesn't.
So if you're running Heroku, go do that now. Add this line. Add this line.
Yeah, that
Free
line.
speed.
Yeah, config.ru, add it. It would make your life so much better. All right, so what did it do this time? Yeah! Woo! Yeah! Calm down. So we've shaved off another second. So let's go back to this little puppy now. To move over to the right, we want to see what we can do about this section now. So we've optimized before the green line a bit. The purple area there, just if you want to know, is we're using a jQuery plugin called Masonry to kind of arrange the GIFs in a certain visual style. That is the DOM content loaded event firing. Sorry, DOM content ready event firing. The JavaScript rearranges a whole bunch of stuff on the page, and that's just some really slow JavaScript running, because you can see it starts. See if I go back. See the JavaScript line there, the blue area. The purple area kind of starts when the JavaScript finishes. So we fix this later on, but just FYI, purple is bad. So we're going to try and optimize this section now.
Yep.
Cool.
So on our GIF topper website, we have two types of assets. The first asset we'll look at is the user uploaded GIFs. So when someone adds a GIF to GIF topper, what we do is we grab we convert it to a JPEG, so we can convert. We grab that first slide. So we were already doing this. We already had this preview uploader, and we were converting this to our JPEG, like you see here. But now what we want to do is we want to make sure that JPEG is going to be as small as possible. So a cool thing to do is we can actually strip all of the metadata out of the image. Now that's data that is present in the image, contain like EXIF data, color profiles, things like that. Stuff that isn't used to render the image, so it's not useful here.
Yeah, stripping's really good, especially if you've got any uploads from a mobile device. Stripping will actually strip all the geolocation out of images. That's a big tip, because sometimes if you offer uploads from mobiles and you show the source, you may theoretically be giving away someone's location at the time. So it's a good idea generally just to strip all the metadata from your user uploaded content.
Yeah, and protect your users is really cool. Another thing we're doing, so we're also reducing the quality. So we're using lossy compression here to reduce the JPEG size. They're quite small, and even with 80% here, so that's the quality percentage, even with 80%, there's a very tiny visual difference. It's very hard to spot with the naked eye. So 80 is a good number for us, but obviously depending on the size of the image, if it's much bigger, you might want to have a higher percentage of quality. So that's what we did for our upload images. We use carrier wave, and this functionality is provided by the carrier wave processing gem. That's what adds the strip and the quality stuff here. So the next kind we have is our theme assets. So we have our logo at the top. We have one more image, I think. And so with all those images that we're putting into our site for our theme, they're going to contain information that we can strip out. So there's a really cool tool if you're running OS X called Image Optim. And what this does is it does lossless compression. So the image won't change at all. We're stripping out the metadata. This actually runs through quite a few popular open source tools. There's things like PNG Crush, JPEG Optim. There's quite a few, and it basically runs through all of them to find the best size it can. So you just dump in a folder here, and it'll do your like the entire folder and replace the file.
Yeah, there's really no reason why you shouldn't be doing this. It's simple as pretty much dragging your app assets images folder directly into this. It'll replace the files in place, so you can kind of just do this before you commit, and everything will be great.
The one problem with this is you got to remember to do it. So hopefully there was an automated solution that used some of the stuff that this does, but it hasn't been maintained anymore. So hopefully maybe someone in this room might like to write something that maybe will hook into the asset pipeline and do this for us automatically. That'd be great. Another trick is if you've got multiple images, you can combine the images into one file, and that'll compress them much better. And then we can use CSS to position them around the page. The downside of that is it's quite intensive. You've got to stitch these photos, the images together. You've got to keep the coordinates. It's very difficult. So tools like Compass will do this for you automatically. Or you could consider using a font library, which is quite small in size. You've got the benefit of you can show it in any size, you can color them, they'll scale up really nice. So
the font library is essentially lots of small little, I think, vector images inside a font file, and instead of the character A, it's like a plus button. The great thing of using a font, obviously, is if you've got retina displays, you get nice crisp edges instead of like pixely edges. So,
cool. So we compressed our images, and then we got this. Yay!
Oh, very enthusiastic audience
yes.
this morning. Very
excellent. Wait till later. I'll be surprised. It says you here.
Ah, it's me. There you go. So what we're going to look at now is this big purple area and this very scary looking JavaScript. Now, this is the JavaScript is what we're commonly knowing. What it's doing, it's blocking the page. That's what it's doing. It's blocking the user from seeing anything because it's running this JavaScript and it's moving the page around. So what we're going to try and do now is try and move this green line, that start render time, further to the left. You want that green line as further to the left as possible. This is the JavaScript I'm talking about. We're going to fix this problem now. And a common solution is to put the JavaScript at the bottom, which is kind of cheating. What we do is we take this JavaScript, just the line, as you see here, and move it to the very bottom of the HTML, which means that the start render time will be much further because we don't have to pay the JavaScript cost so soon. There's a small problem with this though. If you've got little bits of inline JavaScript throughout your page to do some jQuery things, like a jQuery.ready call or something, those won't run anymore because the jQuery object won't exist by the time that code runs. So you're going to have to, we'll show you how to deal with that in a minute.
Another thing to note is it still does block, but we basically loaded everything on the page and then we're blocking afterwards. So yes. It's okay, you'll still see everything and then we sort of block.
Yeah.
So, yeah.
So doing that hasn't taken another second off. Now we're down to about 5 seconds. So we've gone from 9 seconds to 5 seconds. But we've got this 2-second goal. So let's go deeper. Next thing we're going to do is asynchronously load the JavaScript. Now, instead of blocking when we load the JavaScript, we're going to let the browser continue to render and download the JavaScript asynchronously. There's a couple of libraries to do this. You can actually just add an async tag on the script tag itself, and that will do the same thing, but not all browsers support it. It's a bit funky, so there are a couple of JavaScript libraries out there that kind of make it work consistently. We chose Head.js. So one thing to note about Head.js is that it's small. If you get it's modular, so you can kind of strip out what you want. We stripped out the script loader. The script loader itself is about 1 or 2 kilobytes. Yep. Now, previously we talked about latency. If you include your script tag, if you include the Head.js script externally, you are still paying this latency cost. You are waiting about 350 milliseconds to even just grab the file. But if you just embed the entire JavaScript into your page, you don't have to pay that 350 millisecond cost. It's in the page, and it's so small that it's insignificant to render time. Now, some of you will be like, haha, what about caching? Screw caching, you don't need it. It's 1 point something kilobytes. And when it's gzipped, it's like 0 point something kilobytes. So it's It's so small, it doesn't really matter.
Another thing to note is, yes, you are increasing the page size for subsequent visitors, but with minification and gzipping, it is a very small cost, so you need to weigh that up. Another thing to note with these external, if you're doing the async loader externally, is if it's the first time and you're loading that from like another domain, let's say you've got like a CDN or something like that, you're going to have to pay a cost to look up the DNS time as well on that first load, if it's not on the same domain. So you've also got that in mind. That might block it even further. So yeah.
So the TLDR is just chuck the JavaScript in the page. Now, what did this do? It what?
Yeah, made it slower.
This GIF got so much more funny when I looped it back on itself.
This really annoyed us because we really like async loaders.
Yeah,
so
yeah.
well, like,
So-
what are you doing? Like,
so
we've
what
used this
happened?
thing all over the place.
Yeah, bad advice from Mario. That's
Yeah.
his idea. This is what happened. We had one JavaScript file on the page. There was really no point to do an asynchronous loading of the JavaScript because there was only one file. Now, the only JavaScript libraries we had on the page were jQuery, I think underscore, and the masonry plugins. So there's not that much JavaScript. So there was really no point to asynchronously load. We also increased the page size, as Mario said before, because we embedded the head.js script. So what could we have done? Now, I know for sure that asynchronously loading JavaScript is much faster. So what can I do to...
Big claim.
Sorry?
Big claim.
Yeah, it's a great claim and it's correct. What we want to do is split up the assets. Now, how many of you have like this monolithic application.js.erb that's got jQuery, jQuery, backbone, underscore, everything in it? Anybody? Yep. Bad.
Don't do that.
Don't do that.
Bad.
Now, what you want to do is split your assets up into two groups. Commonly edited and not commonly edited. How many of you do you touch jQuery every day? Don't put your hands down. You don't do it. That's a lie. No one touches jQuery. No one touches jQuery UI unless you're a jQuery core member. Then you don't need to edit it every day. So you want to move all of your vendor stuff into a vendor.js.erb. Just split them up. The other benefit to splitting up is that if you change one line of application.js.erb, you're forcing your user to download this entire payload. You force the user to download jQuery again, jQuery UI again.
You've blown the cache.
You've blown the cache for changing this one line. It's silly. So you want to split them into two groups. Commonly edited, not commonly edited. Vendor.js.erb, application.js.erb. It's a very simple thing to do.
The great thing with this is the async loader. It'll actually download the different scripts asynchronously. So it'll it'll make a request to get your vendor, or make a request to get your application.
At the same time.
But then you can it'll actually execute in serial. So what'll happen is it'll download the entire jQuery library before it executes your application.js. So you don't have to worry about is jQuery loaded. As long as you put them in that order, it'll do the parallel, but then execute them serially. So that's good.
One more thing more to watch out for is your load and DOM content loaded events. So what does this mean? Now, we are loading the JavaScript asynchronously. We don't know when it's going to get run. Is it going to get run, if it downloads really quick, it may run before the browser fires its load or DOM content loaded events. If it loads slow, the script may execute after these events get run. So what do? If you're using jQuery document.ready inside your scripts, ready will kind of queue up those functions before these events get fired and execute them or when they get fired. If these events have already been fired, they'll run them on the fly. They'll run them straight away. jQuery.ready does not do that. Document.ready does. So try to avoid using jQuery.ready when you're using asynchronously loaded JavaScript.
It's me? Yeah. All right. Okay, cool. So the next thing we've done that, we've knocked off a bit of time. Or knocked off. We're not very good scientists because the number went up, and but we'll continue on. The one problem we have is so our website's hosted in the US on Heroku. I really wish they had a Heroku locally in Australia, especially if you're making websites where the majority of your users are in Australia, because the problem is we've just got this giant latency to the States. So the problem is most of the stuff you're going to be hosting on, we've got this giant latency, so that can be as low as 200, 300 milliseconds from Australia here. So you can experience this if you go to tweet. You'll notice it does take longer. So we want to try and find a way to combat this latency, because if you think about it, we've got this 300 milliseconds that we're going to pay once when we go to negotiate our HTTP connection. We're going to pay it multiple times again when we do things like our assets. So there's we want to try and really get around this fact without changing our hosting.
If you've got like 20 assets on the page and you're downloading them from the US, you have to pay this 300 millisecond cost with every asset. Now 300 times what I said 20 is
it's many numbers.
Many numbers.
Yes.
So
yes,
it's more than 0, which is not fast enough.
Yes. You'll pay many times, maybe not for every asset, but like there's a definitely cost there. So the cool thing is go get yourself CDN. CDNs, when I first started web, were very expensive, and only if you're making a lot of money already could you use one. But nowadays they are accessible to the common developer. So we found this one. We popped it in. So what we did was, at the moment our assets are on Heroku. We want an easy way to pop our CDN on top of that without having to worry about, is this a dynamic page or is this like an asset? So what we do is we use this awesome little gem that works with the asset pipeline called Asset Sync. It just basically moves our assets to some third-party provider, so some fog-compatible provider. So we can use, for example, Amazon S3, we can use Rackspace Files, we can use anything we want. So we put them somewhere else. We also needed to make sure, previously we were gzipping our assets, but we need to make sure now that we're moving them off that they're still going to remain gzip, so we need to set that too. So we added a CDN just for our assets, and then this happened. Yep.
Hey! Whoa!
Yeah.
Whoa! Oh, come on!
Yes.
Come on! Almost there! Almost there!
Almost there. So we're almost at our goal.
So one thing that I wanted to quickly talk about was the choice of CDN. On desktop, we originally used CloudFront, which is an AWS solution.
Very good.
CloudFront is very good. It's a very, very good service, but when we were serving lots of wallpapers, our bill was getting into the hundreds. And it's because it's just Mario and I, we couldn't really afford it. So we did some digging around and found Cloudflare, not CloudFront. Now, Cloudflare has a plan that we use, which is a flat fee of $20 a month for the CDN, and it gives slightly better performance than CloudFront. So you should definitely check that out if you're a struggling startup.
I guarantee we're not associated with them, we're just fans. Okay, moving on. So the next thing, so we're almost, we're like so close, right? So we just need to do one more thing, maybe to knock off 79 milliseconds, and then we can go home. So the next thing we tried to do was we tried to add multiple asset hosts. Now, being a gift sharing website, we've got multiple assets on the page. I think we probably have about 10, 20, 30 maybe assets on that homepage. And the problem with browsers is they have a limit of number of connections they can make per host. Most browsers, I think it's around 6 connections. So the problem with that is we can download 6 images, and then when sort of they start finishing them, we can look at the next 6. And that's a real problem because it slows it down. Ideally, what we want to do is we want to just download them all at the same time and avoid paying that latency cost multiple times. So so what we did was we added multiple asset domains. So this is really easy to do with Rails. If you put a %d in your asset host, so where your external files are, it'll automatically grab the file, it'll get the sum of the file, and then it'll get the modulus of 4. So that'll work out 0, 1, 2, or 3, and then that'll be the exact same for the file. So when you subsequently visit the page, the same assets are going to be on the same host, so they're going to be cached. For our carrier, we had to do this as well. Ignore the double lambda, it's a slight hack, but it achieves the exact same thing. So yeah, so we did that, and it got slower, but I don't have the little slide. So the problem was we weren't. The problem was we couldn't figure it out. We ran it was slower, but we had this huge standard deviation. It kept on varying widely, and we couldn't really figure out. We sat for a while, and we were almost going to ditch this technique because we just couldn't prove that it was any better. And so we looked at what was happening, and we noticed that because we're simulating a first-time load, every single time we hit a new asset host, it was paying a DNS lookup time. So we don't have the DNS, we've got to go get it, and that was what was pushing us over. So that's why it was slower. So what we did was at the very top of our page, we had 4 of these lines, one for each of our external asset domains. And this happened. Oh no. Okay. Another tip is if you're serving your assets from the same domain as your application, if your cookie covers the entire domain, the cookie might also be getting sent with every request for your assets. So what you should do is try and use a domain that doesn't have those cookies associated with it. You can imagine if you have 30 assets a page, your cookie's 1 kilobyte, it's got to come up and down. It's just extra data that we just don't need to send. So getting a domain that doesn't have any of those application cookies associated with is really important here as well. So when we added the when we added the multiple asset domains, yay! Yes.
Yes. All achieved.
We're very happy. So then we went home and had beer. But then we thought maybe we'd do one more.
Yeah. We can go deeper.
We can go deeper. So we were playing with this really cool new thing that so some people really seem to like and some people don't seem to like. So we seem to like it. It's called Speedy. So Speedy is actually a completely new networking protocol. It works with HTTP. It's not a new HTTP. It doesn't require HTTPS. It doesn't require a secure connection, but most of the time it's implemented with it. And the great thing about this is if your site is hosted under SSL, so if you've got a secure site, with logins, with stuff that you're serving over a secure connection, you're already paying some extra latency cost for the SSL, and so we can reap some of that back with Speedy.
Yeah, SSL is much slower.
Yep.
SSL and speed is entirely different talk, so we don't want to go too much into it now, but I encourage you, if your site is SSL, Google SSL with speed. Cloudflare, our CDN, has this great toggle of Speedy on for asset domain, so we could just turn on Speedy just like that with our assets, which is great.
The great thing about Speedy is we also don't need to use multiple asset domains, multiple hosts, sorry. So the way Speedy works is a little bit different. We don't actually have a connection limit. What happens is we open one single connection to the server, and then it requests everything. It requests all those files, and they come down through the same connection through a stream. So with a regular file download, you have to open up a TC connection, open it up, ramp it up, and we can just do that once and avoid doing that multiple times. Some other things that it does that we didn't do is you can actually get it to push files to a client. So what does that mean? That means if you have a HTML file that you're serving and you know for a fact that the client's going to ask for the CSS and the JavaScript, you can say, hey, I got this request for this HTML file. You'll also need these files. Here they are. And you can push them through that one connection, saving extra lookup.
Yeah, that's just some real neckbeard stuff. So ask the nearest neckbeard on how to do that, because we don't know.
We're not sure. Not sure. So we did it. Yeah.
It's faster again.
Well, yeah. So then we quit. Yeah. Because it was good enough. We're done. So at the very start, we're loading in over 9 seconds. Over 9 seconds, very slow.
Over 9,000 milliseconds.
9,000, yeah. And then now we're loading in 1856. Also, we used math to calculate the column height, so it was very difficult on us. So please be nice. Yep. I think they're great.
Yep. So this was our waterfall chart beforehand. Sorry.
Yeah.
Wrong microphone. This was the waterfall chart beforehand. Whoa!
Notice notice the headings at the top. When it changes, they're not going to be the same, so it's more dramatic. More dramatic. So this is drama. 6 seconds here. Do it.
Oh, what?
It's 1.6.
There we go.
So straight down. Yeah. That's what we want. It's everything in parallel.
And
so we still,
and it's secure on the left. Look at the lock.
Yep.
Our assets are secure.
Only assets. No content. It was too slow.
No more.
We couldn't. We were We were trying to do this, and we needed to use the same CDN to keep consistent results, but we couldn't get. We couldn't get multiple asset hosts, so we actually were trying at one point to point a CDN to another CDN to the, and there was a whole thing, so we couldn't get it under SSL. I'm sorry, the host, but everything else is.
Anyway, moving on. So a couple of other things that you can try. The HTML5 history API has been recently started to get a bit of traction. What it essentially is a JavaScript API that lets you edit the URL. Just change it. No more ugly hash anchor thingies. So if you couple that with some AJAX requests, you can only download the HTML using some magic JavaScript and kind of replace the HTML instead of doing full browser requests for every subsequent request.
Magic.
It's commonly known as PJAX. It's a default in Rails 4 under a new gem called TurboLink, so check that out. One other thing you don't worry about is third-party JavaScript. These are things like widgets, analytics trackers, those sorts of things. Be very careful of those. We've all been in this situation.
Yeah.
We've been in this situation, so we put ourselves in this situation.
Keith, Keith, I was working on a site where this happened to me, and in development, so we had no social links, and then all of a sudden we got a request from a client, hey, we want the little buttons.
We love them.
We added them, and don't get me wrong, used correctly, they are force for good.
Yeah, maybe.
But used incorrectly, all over the place, like you're about to see, not so good. But
so we put them in, and this is what happened. Oh,
hey.
That's outrageous. Who's heard of Firefox 3D View? Have you ever looked at social buttons in 3D View? Watch.
Oh. The black ones are iframes.
Yeah, they're
There's
iframes.
3.
That's beautiful. It's a beautiful thing.
Yeah.
So that's that. So that's some speed stuff. We've got one more announcement to make. It's very exciting. I'm excited. Are you excited?
I'm very excited.
I'm very excited. What's going to happen?
Do it.
Gift Topper is open source.
Yay!
Yes. It's a stripped down version of Desktopper, so feel free to add features, copy it, do whatever you want. It's free. Enjoy.
Go nuts.
That's it.
Yeah.
That's us.
Next.
Thank you so much.